Now we're in section 3.4, and we're going to take a look at how to multiply algebraic expressions together. Let's start off with the rules for exponents. So these are going to be the rules of how to handle exponents. And let's start here. If you take some expression, x to the n, and you multiply it by some other expression, x to the m, where the bases are the same, right? You've got x here and x here. But here's what you do with the exponents. If you've got a multiplication, what you do is you add the exponents together. Here's a quick example. If you have x squared times x cubed, you get x to the 2 plus 3, which is x to the 5th. Now, if you take a power like this one, x to the n, and raise it to a power, so now you've got a power raised to a power, now you multiply the exponent. So this is going to be x to the n times m. An example here might be this. Say we take x squared and we raise it to the third power. This is x to the 2 times 3, x to the 6th. And now if we've got a product, say we have something like this, x, y, and we raise that to the nth power. Now as long as what's inside is a multiplication, we can distribute the power. So this is going to give us x to the n, y to the n. And an example might be this. Say we have 5x squared, and we're going to cube this. Now I notice that what's inside here is a multiplication, so I'm going to distribute the 3 to the 5 and the 3 to the x squared. So this is going to be 5 to the 3, and then x squared to the 3. 5 cubed, 5 times 5 is 25, times 5 again is 125. And now this one here, I'm raising a power to a power, so I'm going to go back to use this rule here. I'll raise a power to a power by multiplying those exponents, x to the 6th. So sometimes we add the exponents, sometimes we multiply them, sometimes we distribute. So here's a way to keep track of what you're going to do with the exponents. You know the order of operations. So as you go, I'll do it up at the top right here. As you go left to right through a numerical expression, you raise things to powers first and then take roots. So powers and roots first. Then you come back left to right. You do multiplications and divisions. Then you come back left to right. You do additions, subtractions. Now, you can think of multiplication as really repeated addition. Right, like 5 plus 5 plus 5 is 3 times 5. You can think of raising to a power, exponentiation, as repeated multiplication. Right, like way down here, 5 cubed is 5 times 5 times 5, repeated multiplication. So what we have here is that one operation applies to the one directly below it. This to this directly below it, this to this directly below it. But this does not work. You can't go from 1 to below it. So here's what we're getting at. Suppose you're looking at this, x to the 4th, and you're going to raise it to the 6th power. Now, look at what you've got globally. What I see, which of these operations up here do you see? Do you see an addition or a subtraction? No. A multiplication or a division? No. Do you see a power? Yeah, I'm seeing a power. So what's right below power? Multiplication. That tells me what to do with these. I'm going to multiply those. So this is going to be x to the 4 times 6, or x to the 24th. Now, let's take a look at this one here. When I look at this globally, I'm seeing a power again, right? You see something to the 4th power. Now, what do I do here? Well, look inside. It's multiplication. Now, here we are at power, right? X to the 4th to a power. Right below is multiplication. That means I can actually distribute this. So if I distribute, it's going to look like this. 3 to the 4th, x to the 4th, and 3 to the 4th turns out to be 81 x to the 4th. Now what about this one? What if you had x plus 5 squared? Now what I'm seeing here is a power. So all the way up here, for power, what's right below it? Multiplication. But what have we got down here? This is an addition. This operation is 2 below power, so I cannot distribute. I can't distribute the 2 here and the 5 here. All right, so let's make it clear. Let's write this as not equal to x squared plus 5 squared. We'll see what it is soon. Now what if we have this one here? Say we have x to the 4th, y squared, x to the 6th, y. This is all a multiplication. So multiplication, when I see the x's, right, what we're here at multiplication, right? I got a multiplication, follow it all the way up here. I'm at multiplication. So what I do with the exponents, one below is I add them. So this is going to be x to the 4 plus 6, and then y, because I'm multiplying, I add the exponents. 2 plus 1, so I get x to the 10th, y to the 3rd. Okay, so how about in this first one here? C to the 13th times C to the 5th. All right, well, we're multiplying. So what do we do with the exponents? In problem number 2, we're still multiplying, so I'm going to add the exponents. Now you can probably do this in your head, but here's what you should be thinking. 4 plus 7 plus 5, C to the 16. In number 3, we're going to take m to the 7th and raise it to the 8th power. And what I'm looking at, when I look at this globally, I see a power, right? I'm taking something and raising it to the 8th power. So following it up here, if I'm at power, what do? Well, look below it. Right below it is multiplication. So we're going to multiply those exponents. It's going to be m to the 7 times 8. This will be m to the 56. Now, in problem number 4, we got this big multiplication, but notice it's all multiplication. This times this times this. There's no additions or subtractions, so I'm just going to multiply using that addition rule. So let's try this. It's going to be 2 times 6 is 12, times 4 is 48. Now, what about the a's? I got a times a squared. Now, we're multiplying, right? Multiplying, so we add the exponents right below it. We add, so it's going to be a to the 1 plus 2 is 3, and 4 more. So a to the 7th. And then b, we got 1b here, so b to the 1st. 3 here, so 1 plus 3 is 4. And there's no b's over here, so just b to the 4th. Number 5, I'm seeing a power, right? And in a power, that puts us up here. What's right below power? Multiplication. So I look inside the parentheses, and that's what I see as a multiplication. So I can distribute this 2 to all 3 of those terms. So if I do that, it'll be 8 to the 2, and then a to the 7th to the 2, and then b to the 8th to the 2. Then we're raising powers to power, so I multiply, right? Here's the powers, we multiply. So 8 squared is 64. A to the, now just do it in your head, 7 times 2, 14. B, multiply, 8 times 2. We'll get a 16 there. Now look, if you can go from here to here, that's fine. 8 squared, 64. You know you're going to multiply, so you don't have to write this. You can just do it directly. A to the 7 times 2, 14. B to the 8 times 2, 16. Now, take a look at this number 6. What we're doing is I have this term here, or actually this factor and this factor. We're making multiplication, right? It's this times this. Now, we're at multiplication. When you look at this globally, you should see a multiplication. This times this. Now, so you're over here at multiplication. What's right below it? Addition, subtraction. So look inside the parentheses. We have an addition. So we can distribute. As long as we have an addition or subtraction, we can distribute. So this is going to be 4x times negative x plus 4x times 8. And you can probably just do that step in your head. So this is going to be 4x times negative x is negative 4x times x, x squared. Right, you add the exponents. Plus 4 times 8 is 32x. Number 7, I see a multiplication again. We've got 8xy, and we're multiplying it by this two-term, this binomial expression. So we're at multiplication. Here's multiplication. What's right below it? Addition, subtraction. Look in the parentheses. I've got an addition. So we can distribute. We can distribute here and here. So we're not going to write it this time. I'm going to multiply here, and then I'm going to multiply over here. So at that first multiplication, what do you get here? 8 times 2, right? So we're going to get 16, and then x times x, right? X times x is going to be the x squared. And then we also have the y. So I get 16, x squared, and the y. Now, run it over here. Positive 8 times positive 2 is positive 16. And then we've got the x. No x is over here, so we'll just have an x. But then we do have a y times a y, so that's going to give us a y squared. Now in number 8, I'm going to multiply every term in the first parentheses by every term in the second. So the way to think about this is start here with the x, run it through. Let's do it. I'll run the x through, so x times x is x squared. Positive x times negative 4 is negative 4x. And now we've run the x all the way through, so move over to the y, the negative 5. So I'll get negative 5. Let's do it here. Negative 5 times x is negative 5x, and then negative 5 times negative 4 is positive 20. Now let's combine terms. We've got the x squared, which does not combine with anything, but the negative 4x minus 5x gives us negative 9x plus 20. Just as we did in number 8, let's do that in number 9. I'm going to start here with the x and run it through. The first and the first is going to be the x squared. The first and the last, positive x times negative 4 is negative 4x. And now go with this, move over to the 6. Positive 6 times x is positive 6x. Positive 6 times negative 4 is negative 24. These two middle terms will combine, giving us x squared. Now, negative 4x's plus 6x's is plus 2x's minus 24. Let's run the same thing through here in number 10. I'll start with the 2w and run it all the way through. So 2w, let's do it, 2w times w, we're multiplying, right? So add the exponents, 1 and 1 is 2. So we'll get 2w squared, and then 2w times positive 5 is positive 10w. So we've run the 2w through. Now move over to the 9 and run it through. So we're going to get positive 9 times w is positive 9w, and positive 9 times positive 5 is positive 45. The two middle terms will combine. We'll get 2w squared plus, now 10w plus 9w is 19w's plus 45. Same idea here in number 11. We're going to run the 2a through, and then we're going to run the 3 through. Actually, why don't you try this one? Turn the video off, or pause it, and then come back, and we'll see if we get the same thing. So I'm getting 14a squared plus 10a plus 21a plus 15. Two middle terms will combine, so we're going to get 14a squared, 10a's, and 21a's is 31a's plus 15. We get the same thing? Same idea here. 9z times 7z is 63z squared, right? Z times z is z to the 1 plus 1, z squared. And then 9z times 6u, 9 times 6 is 54 ZU. Move over here. Negative U times positive 7C is negative 7ZU. Right? Now, keep in mind, order doesn't matter here. It's multiplication. So ZU, I wrote. If you wrote UZ, that's good too. And then finally, negative U times positive 6U is negative 6U squared. Combining some terms here, those middle terms will combine, so we'll get 63z squared plus 47zu minus 6u squared. Or if you like, that z, you could write that like this. 63z squared plus 47uz minus 6u squared. And you might do this because a lot of us like to write our variables in alphabetical order. So these are both the same. Now, 13. Look at this carefully. We've got 3x, 5y, 5y. But the difference here is this is a plus, this is a minus. So they look the same except one sign difference. There's a name for these. These are called conjugates. And they have a very interesting feature when you multiply them out. Let's do that. Let's take the first times the first. So 3x times 3x, we get a 9x squared. Now look at this outer product. 3x times negative 5y. Positive 3 times negative 5. This is going to give us negative 15xy. Right? 3x, 5y, there's the negative 15 and the x and the y. Now let's move over here. We'll get the positive 5y times positive 3x is positive 15xy. And then the last and the last becomes positive times negative is negative 25y squared. Now look at these middle terms. They go to 0. So what we're going to get is 9x squared minus 25y squared. Now the feature here is this. If you have conjugates, look what you do here. How do you get the 9x squared? You just square the first. Then you write a minus sign. And then the 25y squared, that comes from squaring the second. So if you have conjugates, here's what you do. You square the first, put a minus sign, square the second. And the minus sign comes from the last times the last. So square the first, put a minus sign, square the second. Before we go into another problem, let's just try this one here. See if we get the same thing. So let's take the 4x plus 7, multiply it by 4x minus 7. Now you recognize that they're conjugates. So see if you can get it. Here's the rule. Square the first, put a minus sign, square the second. So square the first, put a minus sign, square the second. So here's what I'm getting. Square the first, I get 16x squared. Put a minus sign, square the second. 49. And if you do it all out, like if you do it term by term, look what happens here. The outer product and the inner product, right? What do you get on the outer? Negative 28x, positive 28x. They add to 0. They just go out. So in 14, what we're going to do now is going to take a binomial, two-term expression, multiply it through this trinomial, a three-term expression. So we're going to use the same idea as we did before, the same procedure. We're going to start with the 6x, the first term, and run it all the way through, all three of those. Then we're going to move over to the 1 and run it all the way through. So let's give it a start. So starting with the 6x, run it all the way through, 6x times x squared, 2x squared. Now 6 times 2, there's a 12. And the x times x squared, right, this is a 1. 1 plus 2 is 3. So x times x squared is x cubed. So our first product is right here, 12x cubed. Then let's run it through the second one, 6x times 6x, about 36x squared. And then the 6x times the 1 is a 6x. Now, run over to the 1 and run it all the way through. So 1 times 2x squared is 2x squared. 1 times 6x, 6x. And finally, 1 times 1, that's just a 1. Let's combine any terms. Any terms that are like terms. So let's go with the 12x cubed. That doesn't combine with any. But I can see here that 36x squared and 2x squared is going to give us 38x squared. And then 6x and 6x, that'll give us 12x's. And then I think we still have that 1 out there, right? So we'll still have that 1. Now, in number 15 here, we're taking a binomial and squaring it. Now, from one of the problems we did earlier, right, if we think this, right, here's our order of operations, powers, roots, multiplications, divisions, additions, subtractions. As we look at this, we've got a power, right? When you look globally, you're seeing a power. Now, what's inside? That's a subtraction. Now, if you start here with a power, a subtraction is 2 below, so we can't distribute. We can only use the one operation directly below it, but we don't have a multiplication or division. We've got a subtraction. That's 2 below, so we can't distribute. So we know we are not going to get, this is not x squared minus 64, right? The first squared minus the second squared. Let's see how this actually goes. So x minus 8 squared is really, if we expanded it out, it would be x minus 8, and now we can apply the other methods, the method we've been using. First and first, x squared. The outer product, positive x times negative 8 is negative 8x. Now the inner product, another negative 8x. And the last, negative times negative is positive 64. The two middle terms will combine, giving us x squared minus 16x plus 64. Now look what we did. How did we get this result? There's a little pattern for this, so you can just talk your way through here. How do you get the x squared? Well, you square the first, right? So here's the pattern. You square the first. Now how do you get to 16? That came from the negative 8, negative 8. And if you come up here, if you multiply these two together, but you have to double it, right? Because it appears twice. It appears twice. One from the outer product, one from the inner product. So let's run through the pattern so far. X squared. Square the first. Now to get this, you multiply these two together, negative 8x, and double it. Gives you that. Now where's the positive 64 come from? That's a negative 8 times negative 8, so you just square the last. So here's the pattern. Square the first, right there. Multiply these two together, double it, right there, and then square the last. Now, if you don't want to remember the pattern, you can just write it out like this. It always works. Let's just try this while we're doing this. Let's go with this. What if we have y plus 6 squared? Now, here's how the pattern goes. Square the first, so you might try to write it. Square the first. Multiply these two together, 6y, and double it. And then square the last. So if I do that, I'm going to get this. Square the first, y squared. Now multiply these two together, 6y, and double it. So if I double 6y, I get 12y, and then square the last, 36. Now again, you could write that as y plus 6, and multiply it all out, combine the middle terms, and this is right where you'll be. Let's try the pattern on this one. We've got a binomial and we square it. So here's what we do. We square the first term, 36x squared. Now multiply these together and double it. I'll get 18x, but if I double 18x, I get 36x, and then square the last. So if I square the last, I'm now at a 9. Now, if you're not sure about that pattern, you could write this as 6x plus 3, 6x plus 3, getting 36x squared. Positive times positive is positive 18x. Now over here, there's another 18x. And finally, a plus 9, and these two will combine to give us 36x squared plus 36x plus 9. So we can get it either way. This pattern is just a little bit faster. 17, let's square again. Squaring a binomial. So we're going to square the first, getting x squared. Multiply these together. Positive times negative is negative 3x, but you double it, so you get negative 6x, and then you square the last. You get plus 9. And we all know that this thing is not equal to, you can't just square the first and then square the second. Now in this problem here, we're not squaring, we're cubing. So how about if we do this? We're just going to have to multiply this one probably out like this, but notice what we could do is I could write this as x minus 4 times x minus 4 squared, right? Does it make sense? 1 plus 2 is the 3. I'm going to write it like this because I know what to do here. So this is going to become x minus 4 times, now we know how to do this. Square the first, Multiply the two together, negative 4x, double it, negative 8x, and square the last, plus 16. So let's multiply through like we've been doing. I'll start with the x and run it through all three. So let's do that. So x times x squared is an x cubed. X times negative 8x is negative 8x squared, and x times 16 is 16x. Now we're going to bring it to the negative 4. So we're going to have negative 4x squared, and then negative 4 times negative 8x is running out of room here, plus 32x, and then negative 4 times positive 16 is negative 64. So let's combine terms. There's only one of those x cubes, but the squareds, we've got negative 8 of them here, and we're going to subtract 4. So it's minus 12x squared, and then 16x's and 32x's is 48x's, and then just that minus 64 out here. That should be it. Now, in problem number 19, we have a rectangle whose length is x plus 3 and whose width is 2x minus 3. And what we want to do is we want to get an expression for the area. Now, we know this. The area is the length times the width. So the area is going to be the length, x plus 3 times the width, 2x minus 3. Let's multiply these. A is equal to, all right, first and first is 2x squared. The outer, right, x times negative 3 is negative 3x. The inner product, 6x. And then the last and the last is a minus 9. Combine those middle terms. So here's the expression we're going to use for the area. We've got 2x squared. Now, negative 3x plus 6x is plus 3x and then minus 9. That's what we're looking for as an expression for the area. Now, in problem number 20, this is the last one we'll do in this section, we're given this, that the total production cost, we're going to use P for that, P for production, of Y pills. We're going to produce Y number of pills that are used for lowering blood pressure, and here's the expression for it. It's 132 times Y plus 2 times Y plus 9. So can we just simplify this? Actually, I don't know if it's simplified, but we're going to expand it out. So we're going to get P equals 132. Now, why don't you do this one first here? So 132 times, now, let's multiply it. We'll get Y times Y is Y squared. The outer product is 9Y, right? Y times Y is the Y squared. Y times 9 is the 9Y. And then the inner product, plus 2Y. And then the last and the last, 18. Simplify a little bit here. We'll get 132 times Y squared plus 11Y plus 18. And now with my calculator, I multiply through here. I'm going to get this. P is equal to 132Y squared. And then 132 times 11 is 1452 Y. And 132 times 18 is 2376. There is our expression for the production cost.